Greetings, and thank you for joining me on this peaceful exploration through the numerical wonders that surround us, where digits waltz with creation and designs murmur the mysteries of universal balance. I'm so pleased you've chosen to spend this quiet time with me tonight. Wherever you happen to be discovering your sanctuary of calm, maybe you're settled into your beloved armchair, observing the final glimmers of daylight disappearing beyond your window pane, or perhaps you're tucked comfortably under warm covers as the outside world transitions into evening's tender hold. Allow yourself a moment to feel the steady pulse of your breath, the comforting heaviness of tranquility descending upon your frame, the way darkness gradually lengthens and softens as night draws near. No matter where you find yourself in this magnificent, connected universe, I trust this examination of one of arithmetic's most captivating and enigmatic sequences will offer you gentle companionship as you wind down towards slumber. This evening we shall venture through one of the most mesmerizing revelations in all of numerical science. A progression of digits so elementary that any youngster could grasp it, yet so deep it unveils the secret blueprint of existence itself. We'll uncover coils that manifest in star systems countless light years distant, and within the compartments of a delicate sea creature's shell, we'll find identical numerical harmonies in the positioning of flower parts, the splitting of waterways, the framework of our breathing organs, and the cadence of our pulse. It's a tale that starts with an ancient scholar contemplating breeding pairs and culminates with understanding about the essential nature of expansion, elegance, and existence itself. This enchanting progression is called the Fibonacci series, honoring Leonardo Fibonacci, an Italian scholar who existed more than 8 centuries past. Yet the design he documented has been flowing through the cosmos since time began, patiently awaiting inquisitive spirits to uncover its mysteries. The digits themselves appear almost laughably straightforward: 0, 1, 1, 2, 3, 5, 8, 13, 2, 1, 3, 4, 5, 5, 8 is 13, 2, 1, 3, 4, 5, 5, 8 is. Each digit simply represents the total of the pair that preceded it. Still, from this modest start springs a design so magnificent and so widespread that it seems to be among the core organizing forces of creation itself. Before we plunge further into this numerical marvel, allow me to emphasize that tonight's voyage is purely for the pleasure of exploration and the serene fulfillment of comprehension. Like observing celestial bodies appear individually in the deepening heavens, or hearing the soft pulse of surf against the coastline, arithmetic at its most splendid provides us a meditative peek into the graceful designs that direct our reality. Tonight's investigation will guide us through ideas that have amazed and charmed number theorists, painters, builders, and researchers for ages. We'll learn how a basic series of digits links the tiniest blossoms in your yard to the vastest star clusters in space, exposing a cosmic melody of numerical harmony that plays silently everywhere around us. Our tale starts not with intricate formulas or theoretical concepts, but with something wonderfully tangible: an inquiry about breeding animals. In the year 1202, Leonardo Fibonacci presented a seemingly straightforward puzzle in his work Fibonacci. He wondered, if you begin with one breeding pair, and monthly every adult pair creates a new pair, and these creatures need 1 month to develop, how many pairs will exist after 12 months? This practical question about animal numbers would result in one of the most significant findings in mathematical history, a finding that would eventually expose the underlying numerical framework supporting much of the living world. To answer his breeding puzzle, Fibonacci devised a series that begins simply enough. During the opening month, you possess 1 pair of creatures. In the following month, you still possess 1 pair, since they haven't developed yet. However, in the 3rd month, that initial pair creates offspring, providing you 2 pairs altogether. In the 4th month, the initial pair creates another young pair, but the pair born in month 3 isn't yet developed, providing you 3 pairs, and thus the design continues. 1, 1, 2, 3, 5, 8, 13, 2, 1, 3, 4, 5, 5, 8, 13, 2, 1, 3, 4, 5, 5. Each digit represents the complete number of breeding pairs, and each fresh digit is always the total of the 2 earlier digits. What Fibonacci couldn't have realized when he created this simple counting game was that he had discovered one of the most basic designs in all of creation. The series that came from his breeding puzzle would later be discovered in the positioning of kernels in sunflowers, the coils of pine cones, the branching designs of trees, the framework of star systems, and innumerable other natural occurrences. It was as if he had found a secret numerical language that creation itself uses to arrange growth and structure throughout the cosmos. The magnificence of the Fibonacci series lies not only in its simplicity, but in its universality. You don't require advanced arithmetic to comprehend it, just the capacity to combine two digits together. Yet this simple rule, used repeatedly, creates a series that emerges repeatedly in the most varied and surprising places. It's discovered in the count of flower parts. Irises have 3, roses have 5, cosmos have 8, chrysanthemums have 13, in the coil arrangements of cone scales and fruit sections, in the branching designs of circulation vessels and electrical bolts, and in the ratios of marine shells and human forms. But the Fibonacci series holds an even deeper mystery, one that links it to perhaps the most celebrated ratio in all of arithmetic, the golden proportion, often marked by the Greek symbol phi. If you select any Fibonacci digit and divide it by the earlier digit in the series, something extraordinary occurs. As the digits grow larger, this ratio approaches a special value, roughly 1.618033988, and so on. This figure, the golden proportion, has been regarded as the pinnacle of elegance and balance since ancient times, appearing in art, building, and creation with such frequency that it seems to represent some core aesthetic principle built into the fabric of reality. The golden proportion possesses qualities that seem almost mystical. If you have a rectangle whose length and width are in the golden proportion, and you remove a square from one end, the remaining rectangle will also be in the golden proportion. You can repeat this process endlessly, creating smaller and smaller golden rectangles, each one preserving the same perfect ratios. And if you draw a quarter circle in each of these squares, connecting them smoothly, you create what's known as the golden coil, a curve that appears throughout creation with remarkable regularity. This golden coil, born from the union of the Fibonacci series and the golden proportion, represents one of nature's most favored growth designs. It appears in the chambered nautilus, where each compartment is larger than the previous one by the golden proportion. It's found in the arrangement of tiny flowers in a sunflower center, where the coils going clockwise and counterclockwise are consecutive Fibonacci digits. It emerges in the coil arms of star systems, where celestial bodies and gas follow this same numerical curve as they orbit around galactic centers. It's as if the cosmos has selected this particular coil as one of its favorite ways to organize matter and energy. The manifestation of Fibonacci digits in creation is so extensive and so consistent that it has a name, phyllotaxis. This term describes the arrangement of foliage around a stem, and remarkably, the angles between successive leaves almost always involve fractions related to Fibonacci digits. A typical plant might have foliage arranged such that you have to go around the stem 2/5 of a full turn to get from one leaf to the next one directly above it. Both 2 and 5 are Fibonacci digits, and this 2/5 arrangement, which corresponds to 144 degrees, is one of the most common designs in the plant kingdom. But why does creation seem to favor these particular numerical relationships? The answer lies in effectiveness and optimization. When a plant arranges its foliage according to Fibonacci coils, it ensures that each leaf gets maximum exposure to sunlight and rainfall while minimizing shading of the foliage below. When a sunflower arranges its kernels in Fibonacci coils, it achieves the most effective packing possible, fitting the maximum number of kernels into the available space. When a chambered nautilus grows according to the golden coil, it maintains its ratios as it grows, creating a framework that's both elegant and functionally optimal. This link between numerical elegance and practical effectiveness runs deep through the living world. Evolution has discovered, through millions of years of experimentation, that certain numerical designs provide optimal solutions to the challenges of expansion, reproduction, and survival. The Fibonacci series and the golden proportion aren't just elegant abstractions, they're practical blueprints for success in the living world. They represent solutions that work so well that creation has converged on them repeatedly, in contexts as diverse as flower parts and star system formation. The ancient Greeks were among the first to recognize the special aesthetic qualities of the golden proportion, which they called the divine ratio. They used it extensively in their building, most famously in the Parthenon. where the golden proportion appears in the ratios of the facade, the spacing of columns, and many other architectural elements. The Greeks believed that rectangles whose ratios followed the golden proportion were the most pleasing to the eye, and this belief has been confirmed by psychological studies showing that people do indeed find golden proportion rectangles more attractive than rectangles with other ratios. During the Renaissance, painters like Leonardo da Vinci became fascinated with the numerical principles underlying elegance and balance. Da Vinci's famous drawing Vitruvian Man demonstrates how the golden proportion appears in human body ratios: the ratio of total height to the height of the navel, the ratio of the navel to the fingertips, the ratio of the elbow to the fingertips, and many other body measurements all approximate the golden proportion. This discovery suggested that human beings themselves are built according to the same numerical principles that govern flower parts and chambered nautilus shells. The Renaissance painters weren't content to simply observe these designs. They actively incorporated them into their work. Artists used the golden proportion to determine the ratios of their canvases and the placement of key elements within their compositions. Sculptors used it to create figures that seemed naturally harmonious and pleasing. Builders designed structures whose ratios followed these numerical principles, creating buildings that felt inherently balanced and elegant. The result was an art and building that seemed to resonate with something deep in human psychology, speaking to our innate appreciation for numerical harmony. As we explore the Fibonacci series and golden proportion more deeply, we begin to understand that they represent something more than just curious numerical coincidences. They appear to be fundamental organizing principles that operate at every scale of existence, from the quantum level to the cosmic level. In recent years, researchers have discovered Fibonacci designs in the arrangement of electrons in certain materials, in the framework of DNA molecules, in the formation of crystals, in the branching designs of circulation vessels and neural networks, and in countless other natural phenomena. This universality suggests that the Fibonacci series and golden proportion may be built into the very laws of physics that govern our cosmos. Some physicists have proposed that these designs emerge naturally from the way energy and matter organize themselves under the influence of fundamental forces. Others suggest that they represent optimal solutions to information processing problems that appear at every level of natural organization. Whatever the ultimate explanation, it's clear that these numerical designs are not mere curiosities but fundamental features of the reality we inhabit. The study of Fibonacci digits and the golden proportion has also revealed deep connections to other areas of arithmetic. The series appears in probability theory, where it helps describe random walks and branching processes. It emerges in number theory, where it's connected to properties of prime digits and continued fractions. It appears in geometry, where it helps describe optimal packing problems and tiling designs. And it plays important roles in chaos theory and dynamical systems, where it helps describe the transition from order to chaos and back again. One of the most fascinating aspects of the Fibonacci series is its relationship to continued fractions, a way of representing digits as infinite expressions involving whole digits. The golden proportion has the simplest possible continued fraction representation: 1 plus 1 over open parentheses 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 1 plus 1 over, and so on forever, close parentheses close parentheses close parentheses. This infinite expression captures something essential about the golden proportion's nature. It's built up from the simplest possible components, the digit 1, through the simplest possible operations, addition and division, yet it creates something transcendent and elegant. This simplicity underlying complexity is a recurring theme in arithmetic and creation. The Fibonacci series starts with the simplest possible rule: add the previous two digits. Yet it generates designs of incredible richness and elegance. The golden coil begins with simple geometric construction, rectangles and quarter circles. Yet it describes the shapes of star systems and seashells with remarkable accuracy. This suggests something profound about the nature of reality, that the most complex and elegant phenomena often arise from the simplest underlying principles. The psychological appeal of Fibonacci designs and the golden proportion has been the subject of extensive research. Studies have shown that people do indeed find golden proportion ratios more aesthetically pleasing than other ratios, though the effect is subtle and not universal. Some researchers have proposed that this preference is hardwired into our brains, Perhaps as a result of evolution in an environment filled with natural designs that follow these numerical principles, others suggest that our appreciation for these designs is learned, acquired through exposure to art and building that incorporates these ratios. Whatever the mechanism, there's no denying the powerful aesthetic appeal of Fibonacci designs and golden proportion ratios. They appear in classical music, where composers have used Fibonacci digits to determine the lengths of musical phrases and the ratios of musical forms. They appear in poetry, where poets have used Fibonacci sequences to structure verses and stanzas. They appear in dance, where choreographers have used golden proportion ratios to create movements that feel naturally balanced and flowing. The influence of these numerical designs extends far beyond the arts into modern technology and design. Computer graphics artists use the golden proportion to create visually appealing layouts and compositions. Industrial designers incorporate Fibonacci coils into products ranging from smartphones to furniture. Builders continue to use these ratios in contemporary structures, finding that buildings designed according to these principles feel more harmonious and pleasing than those that ignore them. In the field of biology, the study of Fibonacci designs has led to important insights into the mechanisms of growth and development. Researchers have discovered that the genes controlling leaf arrangement and flower development are sensitive to numerical relationships involving the golden proportion. They found that cellular automata, simple computer programs that simulate the behavior of many interacting cells, naturally generate Fibonacci designs under certain conditions. These discoveries suggest that the numerical elegance we observe in creation emerges from the fundamental processes of life itself. The link between arithmetic and biology runs even deeper when we consider the framework of DNA, the molecule that carries genetic information in all living things. The DNA double helix exhibits ratios related to the golden proportion, with the length of a complete term being related to the width of the helix by this special ratio. Some researchers have suggested that this relationship is not coincidental but butts deeper numerical principles governing the organization of genetic information. As we delve deeper into the realm of Fibonacci designs, we encounter phenomena that challenge our understanding of how complex order can emerge from simple rules. Fractal geometry, the numerical study of self-similar designs that repeat at different scales, has revealed that many natural Fibonacci designs are actually fractals. The branching designs of trees, for example, show the same numerical framework at the level of major branches, smaller branches, and tiny twigs. This self-similarity across scales suggests that the same simple numerical rules operate at every level of organization. The study of fractals has revolutionized our understanding of natural designs and has led to practical applications in fields ranging from computer graphics to medical imaging. Researchers use fractal arithmetic to model everything from the framework of clouds to the behavior of financial markets. Engineers use fractal designs to design more efficient antennas and heat exchangers. Painters use fractal algorithms to create complex naturalistic images that would be impossible to draw by hand. The link between Fibonacci digits and fractals becomes especially apparent when we consider the famous Mandelbrot set, a fractal design that emerges from a simple numerical equation. Within the intricate, infinitely detailed boundary of the Mandelbrot set, Fibonacci digits appear with surprising frequency, governing the arrangement of bulbs and filaments in this numerical landscape. This discovery suggests deep connections between different areas of arithmetic that mathematicians are still working to understand fully. The universality of Fibonacci designs has also led to their application in fields as diverse as economics and computer science. The Fibonacci series appears in financial markets, where analysts use Fibonacci ratios to predict support and resistance levels in stock prices. Computer researchers use Fibonacci digits in algorithms for searching and sorting data, finding that these numerical relationships often lead to optimal performance. The series even appears in the analysis of internet traffic and the framework of computer networks. In the field of music, the link between Fibonacci digits and aesthetic appeal has been explored by composers and music theorists for centuries. Some have found that musical compositions based on Fibonacci ratios seem more pleasing and memorable than those based on other numerical relationships. The Hungarian composer Béla Bartók incorporated Fibonacci digits into the framework of several of his compositions, using them to determine the lengths of sections and the timing of climactic moments. More recently, electronic musicians have used Fibonacci sequences to generate rhythms and melodies that seem to capture something essential about the numerical nature of musical harmony. The study of Fibonacci designs in creation has also revealed surprising connections to physics and chemistry. Crystallographers have discovered that certain types of crystals, called quasi-crystals, exhibit five-fold symmetry designs related to the golden proportion. These crystals, which were once thought to be impossible, demonstrate that matter can organize itself according to numerical principles that go beyond the simple periodic designs of ordinary crystals. The discovery of quasi-crystals earned Dan Shechtman the Nobel Prize in Chemistry and opened up new areas of research into the numerical principles governing material properties. The golden proportion and Fibonacci series also play important roles in chaos theory and the study of nonlinear dynamical systems. Researchers have found that systems that exhibit chaotic behavior often pass through stages where their behavior is governed by Fibonacci-related numerical relationships. The transition from order to chaos and back to order seems to follow designs that involve the golden proportion and related digits. This discovery has profound implications for our understanding of complex systems ranging from weather designs to population dynamics to the behavior of financial markets. As we continue our exploration of these numerical designs, we encounter their manifestation in human physiology and psychology. The framework of the human circulatory system, with its branching network of arteries, veins, and capillaries, follows designs closely related to Fibonacci digits. The same is true for the nervous system, where the branching designs of neurons and the organization of brain networks show similar numerical relationships. Some researchers have suggested that these designs are not coincidental but represent optimal solutions to the problem of distributing resources efficiently throughout a complex system. The respiratory system provides another elegant example of Fibonacci designs in human biology. The branching framework of the lungs, from the trachea through the bronchi to the tiny alveoli, where gas exchange occurs, follows a design that maximizes surface area while minimizing energy cost. This fractal-like framework, with its Fibonacci-related ratios, allows the lungs to pack an enormous amount of surface area into a relatively small space, making efficient breathing possible. Even our sensory systems exhibit Fibonacci-related designs. The framework of the human ear, particularly the cochlea where sound waves are converted into electrical signals, follows a coil design closely related to the golden coil. This numerical organization may help explain why certain musical intervals and rhythms seem naturally pleasing to human ears. The visual system shows similar numerical relationships, with the ratios of the eye and the arrangement of photoreceptors in the retina, following designs related to the golden proportion. The psychological effects of Fibonacci designs and golden proportion ratios extend beyond simple aesthetic preference to influence our perception and cognition in subtle but important ways. Studies have shown that people process information more efficiently when it's presented in formats that follow these numerical principles. Web designers and graphic artists have found that layouts based on the golden proportion are not only more visually appealing, but also easier to navigate and understand. The ubiquity of Fibonacci designs in human perception and cognition has led some researchers to propose that these numerical relationships are built into the fundamental architecture of consciousness itself. According to this view, our brains may be naturally attuned to detect and appreciate these designs because they reflect deep organizational principles that govern the framework of neural networks. This would explain why Fibonacci designs and golden proportion ratios seem to have such universal appeal across cultures and throughout history. The ancient philosophical traditions were remarkably prescient in recognizing the fundamental importance of numerical harmony in creation and human experience. The Pythagoreans, active in ancient Greece around 500 BCE, believed that all is digit, and that numerical relationships were the key to understanding the cosmos. They were particularly fascinated by the numerical ratios underlying musical harmony, discovering that pleasing musical intervals correspond to simple numerical ratios. This insight led them to propose that the entire cosmos was structured according to numerical principles, a view that modern science has largely confirmed. The Pythagorean concept of the music of the spheres suggested that the planets and stars move according to numerical harmonies that produce a cosmic symphony inaudible to human ears, but detectable through numerical analysis. While we now know that planetary motion doesn't literally produce sound, The modern discovery of Fibonacci designs in astronomical phenomena suggests that the Pythagoreans were onto something profound about the numerical nature of cosmic organization. Plato, building on Pythagorean insights, proposed that numerical forms exist in a realm of perfect abstractions that serve as templates for the imperfect physical world we observe. According to Plato, the golden proportion and other numerical relationships exist as eternal truths that physical reality attempts to approximate. This Platonic view of arithmetic as a fundamental aspect of reality continues to influence philosophers and researchers today, particularly those who study the mysterious, unreasonable effectiveness of arithmetic in describing natural phenomena. The medieval Islamic world made crucial contributions to our understanding of numerical designs in creation and art. Islamic painters and scholars developed sophisticated geometric designs based on numerical principles, creating artworks that seem to anticipate modern discoveries about fractals and self-similar frameworks. The geometric designs found in Islamic art often incorporate the golden proportion and related ratios, creating visual harmonies that seem to resonate with fundamental numerical truths. The Islamic scholar Al-Kandi wrote extensively about the numerical principles underlying music and harmony, extending Greek insights about numerical ratios to encompass broader theories about the numerical framework of reality. Islamic scholars also made important contributions to the study of optics and vision, discovering numerical relationships that govern how the eye perceives ratio and elegance. These discoveries laid groundwork for later Renaissance investigations into the numerical basis of artistic elegance. During the Renaissance, the rediscovery of classical numerical texts combined with new empirical observations to create an explosion of interest in the numerical designs underlying natural elegance. Painters like Piero della Francesca wrote treatises on the numerical principles of perspective and ratio, while researchers like Johannes Kepler discovered that planetary orbits follow numerical designs related to the golden proportion and Fibonacci digits. Kepler was particularly fascinated by the appearance of the golden proportion in the geometry of the regular pentagon, noting that this five-sided figure seemed to embody the same numerical harmony that he observed in planetary motion. His laws of planetary motion, which describe the elliptical orbits of planets around the Sun, involve numerical relationships that, while not exactly Fibonacci digits, show related designs of harmonic ratio. The scientific revolution of the 16th and 17th centuries established arithmetic as the fundamental language of natural science, but it also raised profound philosophical questions about why numerical designs should be so effective in describing physical reality. Galileo expressed this mystery in his famous observation that the book of creation is written in numerical characters, while Newton's discovery that the same numerical laws govern both terrestrial and celestial phenomena suggested an underlying numerical unity to the physical world. The development of calculus by Newton and Leibniz provided powerful new tools for studying the numerical designs underlying natural phenomena. Calculus revealed that many of the curves and coils found in creation, including the golden coil generated by Fibonacci rectangles, could be described by graceful numerical equations. This discovery suggested that the visual elegance of natural forms reflects underlying numerical harmonies that can be expressed through precise numerical formulas. The 18th century Enlightenment saw further development of numerical approaches to understanding natural elegance and harmony. Scholars like Leonhard Euler made fundamental contributions to the theory of coils and geometric designs, while philosophers like Immanuel Kant argued that numerical elegance reflects the deep framework of human cognition itself. According to Kant, our appreciation for numerical harmony reveals something fundamental about how the mind organizes experience. The 19th century brought new numerical tools for studying the complex designs found in creation. The development of non-Euclidean geometry showed that numerical space could have different frameworks than the familiar flat geometry of everyday experience, while the emergence of group theory provided new ways to analyze the symmetries and designs found in crystals and other natural forms. These numerical advances laid the foundation for 20th century discoveries about the fractal and chaotic designs that govern many natural phenomena. The 20th century saw an explosion of discoveries about the numerical designs underlying natural complexity. The development of computer technology made it possible to explore numerical designs with unprecedented precision and detail, revealing the fractal framework of coastlines, clouds, and biological forms. Researchers discovered that systems as diverse as weather designs, population dynamics, and neural networks all exhibit numerical relationships related to the golden proportion and Fibonacci digits. The field of biomathematics emerged as researchers began to apply sophisticated numerical techniques to understanding biological phenomena. They discovered that the growth designs of plants, the branching frameworks of circulation vessels, and the organization of neural networks all follow numerical rules that optimize efficiency and functionality. These discoveries suggested that evolution itself operates according to numerical principles, selecting for organisms whose frameworks and behaviors follow optimal numerical designs. Modern chaos theory has revealed that even apparently random natural phenomena often follow underlying numerical designs related to the golden proportion and Fibonacci digits. The transition from order to chaos in dynamical systems frequently involves numerical relationships that echo the proportional harmonies found in classical arithmetic and art. This discovery has profound implications for understanding everything from weather prediction to economic forecasting to the dynamics of ecological systems. The development of fractal geometry in the late 20th century provided a numerical framework for understanding the self-similar designs that appear throughout creation. Fractals generated by simple numerical rules can reproduce the complex branching designs of trees, the irregular coastlines of islands, and the intricate framework of clouds with remarkable accuracy. Many of these fractal designs incorporate Fibonacci digits and golden proportion ratios, suggesting deep connections between different areas of arithmetic and natural science. Contemporary research in network theory has revealed that the Fibonacci series and golden proportion appear in the framework of complex networks ranging from the internet to social media to biological neural networks. These discoveries suggest that the numerical principles underlying natural elegance and harmony also govern the organization of information and communication in complex systems. The efficiency and robustness of networks seem to be enhanced when their framework follows designs related to these fundamental numerical relationships. The study of emergence, how complex designs arise from simple rules, has become a central focus of modern science, and Fibonacci designs play a crucial role in this research. Researchers have discovered that cellular automata, simple computer programs that simulate the interaction of many individual units, naturally generate Fibonacci-related designs under a wide variety of conditions. This suggests that these numerical relationships may be inevitable consequences of the way complex systems organize themselves. Research in artificial intelligence and machine learning has revealed that neural networks trained to recognize designs in visual data often develop internal frameworks that mirror the numerical relationships found in natural vision systems. These artificial systems, when optimized for efficiency and accuracy, spontaneously discover the same proportional relationships that appear in biological neural networks and artistic compositions. This convergence suggests that the golden proportion and Fibonacci designs may represent optimal solutions to fundamental information processing problems. The field of computational biology has used Fibonacci designs to understand everything from protein folding to genetic regulation to evolutionary dynamics. Computer models of biological development often generate Fibonacci-related designs when optimized for efficiency and robustness. These discoveries suggest that the numerical elegance we observe in living systems reflects underlying computational principles that govern how biological information is processed and expressed. Modern physics has revealed Fibonacci designs in phenomena ranging from quantum mechanics to cosmology. The framework of atomic orbitals, the arrangement of particles in certain quantum systems, and the organization of matter on cosmic scales all show numerical relationships related to the golden proportion and Fibonacci digits. These discoveries suggest that these numerical designs may be built into the fundamental laws of physics that govern the behavior of matter and energy throughout the cosmos. String theory, one of the most advanced theoretical frameworks in modern physics, incorporates numerical frameworks that involve the golden proportion and related proportional relationships. Some theoretical physicists have proposed that the extra dimensions required by string theory may be organized according to numerical principles related to the Fibonacci series. While these ideas remain highly speculative, they suggest that the numerical harmony we observe in creation may reflect even deeper structural principles governing the fabric of space and time itself. The study of cosmological frameworks has revealed Fibonacci-related designs in the distribution of star systems, the formation of cosmic filaments, and the organization of dark matter throughout the cosmos. Computer simulations of cosmic evolution often generate frameworks that follow numerical relationships related to the golden proportion, suggesting that these designs may be inevitable consequences of the way gravity and other fundamental forces shape the large-scale framework of the cosmos. As we explore the implications of Fibonacci designs for understanding consciousness and human experience, we encounter profound questions about the relationship between mind and arithmetic. The fact that human beings seem naturally attuned to recognize and appreciate these numerical relationships suggests something deep about the framework of consciousness itself. Some researchers have proposed that the brain processes information according to numerical principles related to the golden proportion, which would explain why these designs seem so aesthetically pleasing and psychologically satisfying. The study of meditation and altered states of consciousness has revealed that certain types of mental states seem to enhance our ability to perceive numerical designs and relationships. Practitioners of contemplative disciplines often report experiencing reality as more numerical and harmonious during deep meditative states, as if the underlying numerical framework of existence becomes more directly perceptible when ordinary conceptual thinking is quieted. Research in positive psychology has shown that exposure to natural and artistic designs based on the golden proportion and Fibonacci digits can have measurable effects on mood, stress levels, and overall psychological well-being. Hospital patients recover more quickly when exposed to natural environments or artworks that incorporate these numerical principles, suggesting that numerical harmony may have therapeutic effects on human physiology and psychology. The therapeutic applications of Fibonacci designs and golden proportion ratios are being explored in fields ranging from building to music therapy to garden design. Healthcare facilities designed according to these numerical principles seem to promote healing and reduce stress in both patients and staff. Music composed using Fibonacci ratios appears to have calming and focusing effects on listeners. Gardens and landscape designs that incorporate golden proportion ratios create environments that people find particularly restorative and peaceful. The educational implications of Fibonacci designs are profound, suggesting new approaches to teaching arithmetic and science that emphasize the elegance and relevance of numerical thinking. Students who learn about arithmetic through the lens of natural designs and artistic applications often develop deeper appreciation for the subject and better retention of numerical concepts. This approach to arithmetic education emphasizes discovery and wonder rather than rote calculation, helping students see arithmetic as a living, elegant aspect of the world around them. Contemporary art and design continue to find new applications for Fibonacci designs and golden proportion ratios. Digital painters use these numerical relationships to create computer-generated images and animations that seem naturally harmonious and appealing. Fashion designers incorporate these ratios into clothing and accessories that seem to enhance the natural elegance of the human form. Product designers use these numerical principles to create tools and devices that feel comfortable and intuitive to use. The study of environmental design has revealed that spaces organized according to Fibonacci principles tend to be more psychologically comfortable and functionally efficient than those designed according to other numerical relationships. Urban planners are beginning to incorporate these insights into the design of cities and neighborhoods, creating built environments that work in harmony with human psychological and physiological needs. As we consider the future implications of our growing understanding of Fibonacci designs and their role in natural and human systems, we can anticipate exciting developments in fields ranging from biotechnology to space exploration. Researchers are already using insights from natural Fibonacci designs to design more efficient solar cells, wind turbines, and other energy systems. The same numerical principles that govern the arrangement of foliage on plants may help us design more efficient ways to capture and distribute energy. The exploration of other planets and solar systems may reveal whether Fibonacci designs are universal features of all life-bearing worlds, or unique to Earth's particular evolutionary history. The search for extraterrestrial intelligence includes looking for numerical designs in signals from space, and the discovery of Fibonacci-related designs in alien communications would provide strong evidence for the fundamental nature of these numerical relationships. The development of artificial life and artificial intelligence systems based on Fibonacci principles may lead to new technologies that are more efficient, robust, and aesthetically pleasing than current designs. Computer systems that process information according to golden proportion principles might be more compatible with human cognition and more intuitive to interact with. Robotic systems designed according to natural numerical designs might move more gracefully and efficiently than current mechanical designs. As biotechnology advances, we may develop the ability to enhance natural Fibonacci designs in plants and other organisms, creating new varieties that are more efficient at capturing sunlight, processing nutrients, or resisting disease. The numerical principles underlying natural elegance might guide us in designing new biological systems that are both functionally superior and aesthetically more appealing than existing forms. The integration of Fibonacci designs into virtual and augmented reality systems may create digital environments that feel more natural and comfortable than current artificial spaces. Video games and simulations based on these numerical principles might be more engaging and less fatiguing than those designed according to other criteria. As we spend increasing amounts of time in digital environments, the incorporation of natural numerical designs may become crucial for maintaining psychological and physiological well-being. The study of Fibonacci designs may also contribute to our understanding of consciousness and the nature of subjective experience. If these numerical relationships are indeed fundamental to the way neural networks process information, then understanding them better might help us solve the hard problem of consciousness, explaining how subjective experience arises from objective physical processes. The numerical elegance we perceive in Fibonacci designs might provide clues about the deep framework of consciousness itself. As we approach the conclusion of our exploration tonight, it's worth reflecting on the profound implications of what we've discovered together. The Fibonacci series, which began as a simple exercise in counting breeding pairs, has revealed itself to be one of the fundamental organizing principles of the living world. From the smallest blossoms to the largest star systems, from the framework of DNA to the ratios of the human body, from the branching of neural networks to the coiling of hurricanes, this numerical design appears with such consistency that it seems to represent a basic law of creation. The golden proportion emerging naturally from the Fibonacci series as its limiting ratio appears to embody some fundamental principle of optimal ratio and harmonious growth. Its appearance in art, building, music, and human psychology suggests that numerical elegance is not merely a human invention but a deep feature of reality that we're naturally attuned to recognize and appreciate. The fact that systems optimized for efficiency and functionality often spontaneously develop golden proportion ratios suggests that numerical elegance and practical utility are intimately connected. The universality of these designs across such diverse domains, from quantum mechanics to cosmology, from molecular biology to human psychology, from ancient art to modern technology, suggests that we're glimpsing something fundamental about the numerical framework of reality itself. The Fibonacci series and golden proportion may be signatures of deeper numerical principles that govern the organization of information, energy, and matter throughout the cosmos. Perhaps most remarkably, these designs reveal the deep interconnectedness of all things. The same numerical relationships that govern the growth of a fern frond also appear in the framework of star systems. The ratios that make a human face elegant are the same ones that optimize the arrangement of kernels in a sunflower center. The rhythms that make music pleasing to our ears follow the same numerical principles that govern the branching of our circulatory system. This suggests that we're not separate from creation but are integral parts of a vast, interconnected numerical symphony. The contemplation of Fibonacci designs and the golden proportion offers us a unique form of meditation, a way of connecting with the underlying numerical harmony that pervades existence. When we observe these designs in creation or art, we're not just seeing elegant forms but are glimpsing the fundamental numerical principles that organize reality itself. This recognition can be deeply calming and centering, reminding us of our place in the cosmic order and our connection to the numerical harmony that surrounds us. As you prepare for sleep tonight, perhaps you'll carry with you some sense of this numerical wonder. The next time you see a coil shell on the beach, notice the arrangement of parts on a flower, or simply hold out your arm and observe the ratios of your own body. You might remember that you're looking at expressions of the same numerical principles that organize star systems and guide the formation of atoms. You're witnessing the cosmos's preferred ways of organizing matter and energy, growth and form, elegance and function. In the quiet moments before sleep, when the day's concerns fade into the background, there's something deeply peaceful about contemplating these eternal numerical truths. The Fibonacci series has been unfolding in creation for billions of years, long before humans existed to notice its designs. It will continue to guide the growth of plants, the formation of star systems, and the framework of living beings long after our civilization has become part of history. There's a profound comfort in this numerical permanence, in knowing that some truths transcend the temporary concerns of daily life and connect us to the deepest frameworks of reality. The coil designs we've explored tonight represent a small piece of this eternal numerical reality. They remind us that elegance and order exist at the most fundamental levels of existence, and that human curiosity and creativity can uncover these hidden treasures through patient observation and playful investigation. Whether we're professional scholars, painters inspired by natural forms, or simply curious individuals who enjoy noticing designs in the world around us, we all have the capacity to participate in this great ongoing discovery of numerical harmony. The Fibonacci series teaches us about the power of simple rules to generate infinite complexity and elegance. Starting with nothing more than the instruction to add the previous 2 digits, we create a series that describes everything from the arrangement of star system arms to the framework of pine cones. This suggests something profound about the nature of reality, that the most complex and elegant phenomena often arise from the simplest underlying principles. In a cosmos that can sometimes seem chaotic and unpredictable, the Fibonacci series reminds us that deep order and graceful simplicity lie at the heart of even the most complex systems. The golden proportion, emerging naturally from this simple series, provides us with a glimpse into the numerical principles that govern growth and ratio throughout creation. Its appearance in contexts as diverse as human anatomy and coil star systems suggests that optimal solutions to the challenges of existence often converge on the same numerical relationships. Evolution has discovered these optimal ratios through millions of years of experimentation, while human painters and builders have intuited them through aesthetic sensitivity and creative exploration. The psychological appeal of these numerical designs speaks to something deep in human nature, our innate ability to recognize and appreciate numerical harmony. This capacity for numerical elegance may be one of the things that makes us most human, distinguishing us from other species not just through our ability to create and understand arithmetic, but through our emotional response to numerical grace and elegance. When we feel moved by the ratios of a classical structure or the coil of a chambered nautilus, we're experiencing a profound resonance between our consciousness and the numerical framework of reality. The therapeutic and healing properties of Fibonacci designs and golden proportion ratios suggest practical applications for this numerical knowledge. Healthcare environments designed according to these principles create spaces that promote healing and reduce stress. Gardens and natural spaces that incorporate these designs provide restoration and peace for visitors. Music composed using Fibonacci ratios can calm anxiety and enhance focus. These applications remind us that numerical elegance is not merely abstract but has real effects on human well-being and quality of life. The educational implications of understanding Fibonacci designs are equally profound. When students learn arithmetic through the lens of natural elegance and artistic creation, they develop not just computational skills but a deep appreciation for the role of arithmetic in understanding and appreciating the world. This approach to numerical education emphasizes wonder and discovery rather than rote calculation, helping students see arithmetic as a living, breathing aspect of reality rather than an arbitrary collection of rules and procedures. The technological applications of Fibonacci principles continue to expand as our understanding deepens. Engineers use these designs to design more efficient frameworks and systems. Computer researchers apply them to create algorithms that mirror the efficiency of natural processes. Materials researchers use them to develop new substances with optimal properties. As we face global challenges related to energy, environment, and sustainability, the numerical principles revealed by the Fibonacci series may guide us towards solutions that work in harmony with natural systems rather than against them. The appearance of Fibonacci designs in seemingly unrelated areas of science and arithmetic reveals the deep interconnectedness of all knowledge. The same numerical relationships that govern the growth of plants also appear in the framework of crystals, the behavior of financial markets, and the organization of computer networks. This suggests that the boundaries we draw between different fields of study are somewhat artificial, and that a truly deep understanding of any phenomenon requires appreciation for its connections to the larger numerical tapestry that underlies all of reality. The fractal nature of many Fibonacci designs, their tendency to repeat similar frameworks at different scales, provides insights into the way complexity emerges from simplicity throughout creation. The branching design of a tree is similar at the level of major limbs, smaller branches, and tiny twigs. The coil framework of a star system is echoed in the coil of a hurricane and the coil of a seashell. This self-similarity across scales suggests that the same numerical principles operate at every level of organization, from the quantum to the cosmic. The role of Fibonacci designs in chaos theory and complex systems reveals how numerical order can emerge from apparently random processes. Systems that seem chaotic at one scale often reveal underlying numerical designs when viewed from the appropriate perspective. The transition from order to chaos and back to order frequently involves numerical relationships related to the golden proportion and Fibonacci digits. This discovery has revolutionized our understanding of everything from weather designs to population dynamics to the behavior of financial markets. The quantum mechanical implications of Fibonacci designs suggest that these numerical relationships may be built into the fundamental framework of matter and energy, the organization of electron orbitals in atoms, the behavior of particles in certain quantum systems, and the framework of elementary particles all show numerical relationships related to the golden proportion. These discoveries hint that the numerical elegance we observe at the macroscopic level may reflect even deeper numerical principles governing the behavior of matter and energy at the most fundamental scales. The cosmological significance of Fibonacci designs extends our understanding from the terrestrial to the universal. The coil framework of star systems, the organization of galaxy clusters, and the distribution of matter throughout the cosmos all show numerical relationships related to these fundamental designs. Computer simulations of cosmic evolution generate frameworks that follow Fibonacci-related numerical relationships, suggesting that these designs may be inevitable consequences of the way gravity and other fundamental forces shape the large-scale framework of the cosmos. The philosophical implications of the universality of Fibonacci designs touch on some of the deepest questions in human thought. Why should numerical relationships discovered through the study of digit sequences appear so consistently throughout the living world? What does this tell us about the nature of arithmetic, the framework of reality, and the relationship between mind and cosmos? These questions have engaged philosophers and researchers for centuries and continue to challenge our understanding of the fundamental nature of existence. The aesthetic implications of Fibonacci designs provide insights into the nature of elegance itself. The fact that ratios based on the golden proportion consistently appear in artworks, architectural masterpieces, and natural forms considered elegant suggests that numerical harmony may be a fundamental component of aesthetic experience. This doesn't reduce elegance to mere arithmetic, but rather suggests that numerical relationships may be one of the languages through which elegance speaks to us across cultures and throughout history. The spiritual dimensions of Fibonacci designs have been recognized by contemplative traditions throughout history. The coil has long been used as a symbol of spiritual growth, representing the journey from the outer world of material concerns to the inner world of spiritual realization. The golden proportion has been called the divine ratio, suggesting its role as a bridge between the numerical and the sacred. Many spiritual practices incorporate coil movements, breathing designs, and meditative visualizations based on these numerical relationships. The cultural universality of appreciation for Fibonacci designs suggests that numerical elegance may be one of the few truly universal human experiences. Across different cultures, historical periods, and artistic traditions, we find consistent appreciation for ratios and designs based on the golden proportion and Fibonacci relationships. This universality hints at something fundamental about human consciousness and our relationship to the numerical framework of reality. The continuing research into Fibonacci designs reveals new applications and deeper understanding on a regular basis. Researchers studying plant growth have discovered new mechanisms by which genetic information produces Fibonacci arrangements. Investigators exploring animal behavior have found that optimal foraging strategies often follow Fibonacci-related designs. Scholars continue to discover new connections between the Fibonacci series and other areas of arithmetic, revealing an ever-expanding web of numerical relationships. The role of Fibonacci designs in artificial intelligence and machine learning provides insights into the nature of intelligence itself. Neural networks trained to recognize designs in visual data often develop internal frameworks that mirror the numerical relationships found in natural vision systems. Artificial systems optimized for efficiency and accuracy spontaneously discover the same proportional relationships that appear in biological systems. This convergence suggests that intelligence, whether natural or artificial, may naturally tend toward numerical forms related to the golden proportion and Fibonacci designs. The therapeutic applications of Fibonacci designs continue to expand as we better understand their effects on human psychology and physiology. Exposure to natural environments and artistic works incorporating these designs has measurable effects on stress hormones, brainwave designs, and immune system function. This research is leading to new approaches in healthcare design, stress reduction, and environmental therapy that use numerical principles to promote healing and well-being. The educational revolution sparked by understanding Fibonacci designs is transforming the way arithmetic and science are taught at every level. Students who learn about arithmetic through exploration of natural designs develop not only better computational skills but also deeper appreciation for the elegance and relevance of numerical thinking. This approach helps address the widespread math anxiety that affects many students, replacing fear and confusion with wonder and appreciation. The environmental applications of Fibonacci principles are becoming increasingly important as we face global challenges related to sustainability and climate change. Understanding how natural systems achieve efficiency through Fibonacci-based organization can guide us in designing human systems that work in harmony with natural processes. Biomimetic technologies based on these designs offer promising approaches to renewable energy, sustainable building, and ecological restoration. The space exploration implications of Fibonacci designs may guide us as we venture beyond Earth. If these numerical relationships are indeed universal features of natural organization, then we might expect to find similar designs in any life-bearing worlds we discover. The search for extraterrestrial life includes looking for numerical designs in signals from space, and the discovery of Fibonacci-related designs in alien communications would provide strong evidence for the universal nature of these numerical relationships. The future of human enhancement and genetic engineering may be guided by understanding of the Fibonacci designs that already exist in human biology. As we develop the ability to modify genetic information, knowledge of the numerical principles underlying natural optimization may help us make improvements that work in harmony with existing biological systems rather than disrupting them. The golden proportion ratios already present in human anatomy might serve as guides for therapeutic interventions and enhancements. The development of new materials and technologies based on Fibonacci principles promises to revolutionize fields ranging from construction to electronics to medicine. Materials with internal frameworks based on Fibonacci designs often exhibit superior strength, flexibility, and efficiency compared to those designed according to other principles. These discoveries are leading to new approaches in engineering that mimic the numerical optimization strategies that evolution has perfected over millions of years. The social and economic implications of understanding Fibonacci designs extend into areas like organizational design and economic modeling. Companies and institutions organized according to numerical principles related to the golden proportion often exhibit greater efficiency and resilience than those structured according to other criteria. Economic models that incorporate Fibonacci-related relationships may provide better predictions and more stable outcomes than traditional approaches. The consciousness research implications of Fibonacci designs suggest new approaches to understanding the nature of mind and subjective experience. If the brain processes information according to numerical principles related to the golden proportion, then understanding these designs better might help us solve fundamental questions about consciousness, perception, and the relationship between objective physical processes and subjective experience. The artistic and creative implications of Fibonacci designs continue to inspire new forms of expression and aesthetic exploration. Digital painters use these numerical relationships to create computer-generated works that seem naturally harmonious and appealing. Musicians compose pieces based on Fibonacci ratios that have unique psychological and emotional effects on listeners. Writers and poets experiment with literary frameworks based on these numerical designs, creating works that resonate with the numerical harmony underlying natural elegance. The psychological healing applications of Fibonacci designs offer new approaches to therapy and personal growth. Meditation practices based on visualizing golden coils and Fibonacci sequences can induce states of calm and focus. Art therapy incorporating these designs helps patients process trauma and develop greater emotional resilience. The numerical elegance of these designs provides a non-verbal language for expressing and exploring deep psychological truths. The architectural and urban planning applications of Fibonacci principles are creating built environments that feel more natural and comfortable for human habitation. Structures designed according to golden proportion ratios seem to promote well-being and productivity in their occupants. Urban spaces organized according to these numerical principles create communities that feel more harmonious and connected. As more of humanity lives in cities, the incorporation of natural numerical designs into urban design may become crucial for maintaining psychological and social health. The agricultural applications of understanding Fibonacci designs are leading to more efficient and sustainable farming practices. Crops arranged according to these designs often achieve higher yields with less water and fertilizer. Greenhouse designs based on golden proportion ratios create optimal growing conditions with minimal energy input. Understanding the numerical principles underlying natural plant growth may help us develop agricultural systems that work with natural processes rather than against them. The medical applications of Fibonacci designs extend from diagnostic imaging to surgical planning to pharmaceutical design. Medical imaging systems that incorporate these numerical principles can detect subtle abnormalities that might be missed by conventional approaches. Surgical instruments and procedures designed according to golden proportion ratios often achieve better outcomes with less trauma to patients. Drug molecules structured according to these designs may be more effective and have fewer side effects than conventional designs. The communication and media applications of Fibonacci designs are transforming how information is presented and processed. Websites and user interfaces designed according to these numerical principles are easier to navigate and more pleasant to use. Advertising and marketing materials that incorporate golden proportion ratios are more effective at capturing and holding attention. As we move toward increasingly digital forms of communication, the incorporation of natural numerical designs may become essential for creating media that works in harmony with human psychology. The personal development applications of understanding Fibonacci designs offer new approaches to self-improvement and spiritual growth. Meditation practices based on these numerical relationships can induce profound states of peace and insight. Physical exercises and movements based on coil designs can improve health and vitality. Goal setting and life planning approaches that incorporate these proportional relationships often lead to more satisfying and sustainable outcomes. As our exploration of Fibonacci designs draws toward its close, we're left with a profound sense of wonder at the numerical harmony that pervades existence. These simple numerical relationships, discovered through the contemplation of breeding pairs, have revealed themselves to be fundamental organizing principles that operate throughout the living world and human experience. They connect the smallest details of plant growth to the largest frameworks in the cosmos, link ancient artistic traditions to cutting-edge scientific research, and bridge the gap between objective numerical truth and subjective aesthetic experience. The Fibonacci series and golden proportion represent more than just numerical curiosities. They're glimpses into the deep structural principles that govern the organization of matter, energy, information, and consciousness throughout the cosmos. Their appearance in contexts as diverse as DNA molecules and coil star systems suggests that we're witnessing the signature of fundamental laws that operate at every scale of existence. These designs remind us that the cosmos is not random or chaotic, but is organized according to graceful numerical principles that we're capable of discovering and appreciating. The universality of these designs across cultures, species, and scales of existence suggests that numerical elegance is not merely a human invention, but a fundamental feature of reality itself. The fact that we find golden proportion ratios aesthetically pleasing, that plants grow according to Fibonacci arrangements, and that star systems coil according to these same numerical relationships points to a deep harmony between mind and cosmos, between consciousness and the numerical framework of reality. The practical applications of understanding these designs, from healthcare to building, from agriculture to artificial intelligence, demonstrate that numerical elegance and functional efficiency are intimately connected. Systems optimized according to Fibonacci principles often turn out to be not only more elegant but also more effective, sustainable, and harmonious with natural processes. This suggests that the pursuit of numerical elegance is not merely an aesthetic luxury but a practical necessity for creating technologies and systems that work in harmony with the deeper frameworks of reality. The educational and therapeutic value of these designs reminds us that arithmetic is not just an abstract intellectual exercise but a doorway to understanding and appreciating the elegance and harmony that surround us. When we learn to see Fibonacci designs in creation and art, we're not just acquiring numerical knowledge but developing a deeper capacity for wonder and appreciation that can enrich every aspect of our lives. The spiritual dimensions of these designs offer a unique form of contemplative practice, a way of connecting with the underlying numerical harmony that pervades existence. When we meditate on the golden coil or contemplate the Fibonacci series, we're engaging in a form of spiritual practice that connects us to the fundamental frameworks of reality. This practice can be deeply calming and centering, reminding us of our place in the cosmic order and our connection to the numerical harmony that underlies all existence. The continuing discovery of new applications and deeper understanding of these designs reminds us that we're still in the early stages of comprehending their full significance. Each new scientific discovery, artistic application, and technological innovation reveals new facets of these numerical relationships and deeper connections to other areas of knowledge. The story of Fibonacci designs is far from complete. It's an ongoing exploration that promises to yield new insights and applications for generations to come. The social and cultural implications of these designs suggest new approaches to creating communities and institutions that work in harmony with natural principles. Organizations designed according to numerical principles related to the golden proportion often exhibit greater efficiency, resilience, and harmony than those structured according to other criteria, as we face global challenges requiring an unprecedented cooperation and coordination. The numerical principles revealed by Fibonacci designs may guide us toward forms of social organization that are both more effective and more humane. The environmental significance of these designs provides hope for developing sustainable technologies and practices that work with natural processes rather than against them. Understanding how natural systems achieve efficiency and elegance through numerical organization can guide us in creating human systems that contribute to rather than detract from the health and harmony of the planet. The same numerical principles that create the elegance of natural forms may help us design technologies that enhance rather than degrade the living world. The cosmic significance of these designs connects us to the largest questions about the nature of existence itself. The appearance of Fibonacci relationships in phenomena ranging from quantum mechanics to galactic framework suggests that these numerical principles may be fundamental features of reality at every scale. This discovery invites us to consider whether arithmetic is something we invent or something we discover, and what it means that the cosmos seems to be organized according to principles that we find both elegant and comprehensible. The consciousness implications of these designs raise profound questions about the nature of mind and its relationship to numerical reality. The fact that we're naturally attuned to recognize and appreciate these numerical relationships suggests something deep about the framework of consciousness and its connection to the numerical organization of the cosmos. The study of Fibonacci designs may ultimately contribute to our understanding of consciousness itself and the mystery of how subjective experience arises from objective physical processes. As we reach the end of our numerical journey together, we're left with a transformed perspective on the world around us. The Fibonacci series and golden proportion are no longer just abstract numerical concepts but living principles that we can observe and appreciate in countless aspects of our daily experience, from the coil of our coffee cup's steam to the ratios of our own bodies, from the arrangement of blossoms in a garden to the framework of the star system we inhabit. These numerical relationships surround us with their quiet elegance and graceful functionality. The next time you walk through a garden and notice the arrangement of parts on a flower, or hold a seashell and observe its coil chambers, or simply look in the mirror and contemplate the numerical ratios of your own reflection, you'll be witnessing the same fundamental principles that organize stars into galaxies and guide the formation of crystals deep within the Earth. You'll be seeing the cosmos's preferred numerical language made visible in the forms and designs that surround us every day. In the quiet moments of contemplation, when we allow ourselves to really notice the numerical harmony that pervades existence, we connect with something larger than ourselves, a cosmic order that has been unfolding for billions of years and will continue long after we're gone. The Fibonacci series and golden proportion remind us that we're not separate from this cosmic order but are integral parts of it, expressions of the same numerical principles that create elegance and function throughout the living world. This recognition can be profoundly comforting and inspiring. In a world that sometimes seems chaotic and unpredictable, the discovery of underlying numerical order provides a sense of stability and meaning. We're reminded that despite surface appearances of randomness and disorder, deep designs of elegance and harmony are constantly operating to organize and sustain the complexity of existence. The numerical elegance we've explored tonight offers a unique form of peace and wonder, a way of seeing the world that reveals the extraordinary within the ordinary and the eternal within the temporal. When we learn to see with numerical eyes, every natural form becomes a revelation. Every artistic creation becomes a participation in cosmic harmony, and every moment of appreciation becomes a connection to the deepest frameworks of reality. As you drift off to sleep tonight, perhaps you'll carry with you some sense of this numerical wonder. In your dreams, you might find yourself coiling along golden curves that connect the chambers of seashells to the arms of star systems, dancing to rhythms that follow Fibonacci progressions, or simply floating in the peaceful awareness that you're part of a numerical harmonious cosmos, where elegance and truth are intimately connected. The Fibonacci series will continue its eternal dance through tomorrow and all the days that follow, guiding the growth of plants as they reach toward the sun, organizing the coil arms of distant star systems as they wheel through space, and creating designs of elegance and efficiency that connect every scale of existence in one vast, interconnected numerical symphony. When you wake, these designs will still be there, waiting patiently for your renewed appreciation and wonder. Sweet dreams, fellow travelers in the realm of numerical elegance. May your sleep be filled with golden coils and Fibonacci sequences, with the peaceful recognition that you're part of a cosmos organized according to principles of profound grace and harmony. The numerical truths we've explored tonight are eternal and unchanging, connecting us across time and space to the fundamental frameworks that make existence both elegant and comprehensible. Rest well, knowing that the same numerical principles that create the elegance of flower parts and seashells also organize the neural networks of your sleeping brain and guide the cosmic dance of planets and stars. In the morning, the Fibonacci designs will still be coiling through creation and consciousness, ready to inspire new moments of wonder and new discoveries about the numerical harmony that underlies all of existence. Good night, and may the numerical elegance we've shared together bring you deep peace as you drift into the restorative embrace of sleep, carried along by the eternal coil dance of digits and creation, mind and cosmos, elegance and truth unified in the golden harmony that connects all things throughout the infinite expanse of numerical reality.